We're going to take some time today and talk about the ZWCs that we offer at Lionel. To date, we have shipped two different ZWs, the 6-14124 Post-War Celebration Series ZW and the 6-32930 ZW. The Post-War Celebration Series was shipped with 235 watt powerhouses. Those powerhouses are a 6-12866, 135 watt, 18 volt AC, 7.5 amp powerhouse. The Post-War Celebration Series version came with 235 watt powerhouses and the case. The case in the PWC version was rated for 10 amps per channel. On the front here you see that we have A in common, B in common, C common, and D in common. These are effectively channels. A in common is channel 1, B in common is channel 2, C in common is channel 3, D in common is channel 4. Effectively what that means is we've got A in U, B in U, C in U, D in U. That's pretty basic. On the front of the circuit, on the front of the ZW housing, you have these Molex plugs. Out of the box, it comes with two jumpers. A jumper in the B position and a jumper in the D position. The open plugs is where the plug from the powerhouse that came with the transformer plugs in. So the 135 watt would plug in here and would plug in here, effectively giving you 7.5 amps divided equally, or I should say load balanced, over A and U and B and U. The other 135 watt powerhouse would give you 7.5 amps over C and U and D and U together. So you had 7.5 amps per these two channels, 7.5 amps per these two. The way the ZW is designed is you can remove this jumper in the C and U position, or D and U position, and install another powerhouse here. By removing these jumpers, what you're doing is you're giving a full 7.5 amps to the C and U throttle, and then another full 7.5 amps to the D and U throttle. The same concept applies to the 32930 180 watt powerhouse set. Using the 10 amp powerhouse, 180 watt, you could plug it into the D and U and therefore have 10 amps on this channel, 10 amps on the C and U with its own separate powerhouse, another powerhouse on B and U for 10 amps here, and finally the last 10 amp powerhouse for this channel, the A channel. So effectively what this transformer is capable of doing is putting out 720 watts of power, 4 separate channels, 10 amps apiece. Now, these ZWCs have a jumper inside, which we'll get to in a while. That jumper allows you to control all 4 handles under one address or one throttle. So I can move that jumper internally and control all 4 outputs with just the A handle alone. These ZWCs are designed to be operated with command control or conventionally. What that means is if you have a legacy or a TMCC1 system on your railroad and your legacy base or your command base is on before you apply power to your transformer is going to come up in command mode. When it comes up in command mode, it does not matter what you do with these throttles, nothing will happen until you address it with your remote. All ZWCs respond to TR commands. As you can see, there's a program spot here on the back of the transformer that allows you to program this just like a locomotive. So with the jumper disabled as it is out of the box, I can program this ZW as track 1. What that will do is that'll set throttle A is track 1, B is track 2, C is track 3, and D is track 4. If I put that jumper across the 2 pins internally, and I assign this as track 1, all 4 handles are controlled off the address of TR1. I can then take another ZW and call it TR2 with the jumper installed. The limitations of TMCC1, and because the device is a TMCC1 device being used with a legacy system, the limitations are you can only assign up to 9 TR addresses. So at most, with the jumper installed, to make it what I call a super ZW, meaning all 4 throttles are controlled by 1 track address, you could only have up to 9 super ZWs on a railroad under individual addresses, track 1, track 2, track 3, and so on. With the jumper disabled, as it is out of the box, you can really effectively run 2 modern ZWs on your railroad, because you'll have track 1 through 4, the next one will be track 5 through 8, and it seems foolish to spend the money for a third one when all you're going to get is track 9 out of it, and that's it. You'll have no track 10, 11, or 12. So what we're going to do is we're going to cover how this ZW works, all the features, both conventional and in command. It's important to note that this ZW is the 6-32930. It comes out of the box with 2 of the 180 watt powerhouses. These are 6-22983. You can purchase these separately. So out of the box you get 2 180 watt powerhouses. You can also go out and purchase 2 additional 180 watt powerhouses, so that each one of the 4 channels has a full 10 amps of available power for the track. You can also purchase 135 watt powerhouses instead of the 180s, and then you can have 10 amps on the outside here, 10 amps on the outside here, and 7.5 on the inside. It's totally at your discretion and what's available and what you want to do and what you're doing with the transformer. But the ZWC was designed originally to give you maximum flexibility in your power requirement needs. So now what we're going to talk about is how to hook up your ZWC out of the box. This being the 32930 comes with 2 180 watt powerhouses. Out of the package, your ZW has these 2 plugs in it, or 2 jumpers in it. Basically all these jumpers do is takes the center pin and connects it to the top pin, and it jumps the power from the A terminal over to the B terminal, because out of the package you only have 2 180 watt powerhouses. So let's go ahead and take this Molex connector and plug it into the A channel. I'll take this Molex connector and plug it into the C channel. It's important to note that with this 10 amp supply, we're going to put 10 amps into A and U. This jumper in the B position is taking this power and applying it to the B and U channel. This powerhouse goes into C. We have the jumper in the D position, which is taking the C and U power and jumping it over to D and U. Again, we can remove these jumpers and install a separate powerhouse into that channel, which would then give us 10 amps on A, a separate 10 amps on B, separate 10 amps on C. If we remove this jumper and install a 4th powerhouse, I've got 10 amps on D. Same rules apply if you use a 135 watt powerhouse. That's just going to give you 7.5 amps. Okay, that having been said, your transformer operates based off of power going into the A throttle. So I can turn this powerhouse on and nothing happens. This transformer will not work until the throttle or until the powerhouse going into the A terminal is turned on. As soon as I turn this on, the green light will illuminate. The A channel of the transformer powers the circuit board internally. Without A on, nothing will work. So we got our A channel on. Our command base, our legacy base, was turned on first. So what's happened is our transformer has come up in command mode, because when I turned it on, it detected the 455 kilohertz, or the COM, that comes out of my command base. The same signal that talks to your locomotives is the same signal that talks to this ZW. Inside this ZW there's an antenna, and it's horizontally mounted right on the back of the case facing me. It's picking up the comm from the command base. So I can take these throttles, turn them up and down all day long, and I'm not going to get any voltage out of any of these channels because this transformer is in command mode. It's waiting for me to tell the transformer to increase the throttle through the remote. Doing it manually has no effect over it whatsoever. The reason for that is because this allows you to use the command control system to dial up the power on your ZW to a certain point. So if I know that the A channel, I only want 14 volts, I can take my voltmeter, set it on A and U, dial this up to 14 volts and stop it there, then take my remote and address track 1, assuming that it's track 1, 2, 3, and 4, take my remote, press track 1, dial up my throttle, my voltage is going to come up to 14 volts and stop. And it's not going to go any higher unless I move this handle manually, at which point the voltage will go up to 18 volts. The same works in the inverse. I can have 18 volts out on the track, and I can dial this handle down. It will lower that voltage for me. To turn that power off, I can use the throttle, and that will shut the power off, or I can use my remote and dial that voltage down. We'll show you all of this with a lighted car on the track here in a little bit. Let's program this transformer. In the package with your ZW, you receive, I put it somewhere, here it is. You receive what we call a coupler T-bar. This is just a small piece of plastic that's used to mount a coil coupler on your locomotives. It's a handy tool to have laying around to program your ZW. It comes in the package. You basically make sure that your A channel is on, take the T-bar, you insert it into that hole on the back that says program, and you push down. By pressing that button, the red light should begin to flash. It's not flashing now because this isn't picking up our command signal. So what we're going to do is go ahead and put our command signal closer to the base, or closer to the transformer rather. So I'm just going to take my legacy base and lay this wire over here. If this were connected on the track, I'd have the command base connected to the outside rails of the track, broadcasting a command signal. This would pick it up no problem. So just to make sure we come up in command mode, I'm going to turn the powerhouse off. I'm going to wait a few seconds for the capacitors inside to discharge. I'll turn the power back on. And we're going to press the program button again. Okay, perfect example. This, you see the green light here flashing a little bit? I'm sure it's hard to see on the camera, but that red light is illuminating. It's flashing on and off. You can see the green light pulsing as well. That's telling me that the transformer knows it's in program. So what I'm going to do is I'm going to use my legacy remote. This works the same with a cab 1 remote. I'm going to press TR and 1, and now I'm going to press the set button. You may or may not be able to see, but this red light is flickering. My green light's flickering as well. That's telling me that it's taking the program. When I let off of set, that red light will turn off. The green light is now solid. This transformer is programmed track 1, track 2, track 3, track 4. Let me get a piece of track set up here and I'll show you this firsthand. Now we have a piece of track connected to our transformer. It's important to note that the bottom terminals, the ones closest to the table, are A, B, C, and D. The top terminals are common, meaning they're ground, they go to the outside rail. That's important because if you get it backwards, when you press the whistle button, the bell will come on. You press the bell button, the whistle will come on. So the lettered terminals A, B, C, and D go to the center rail. The top terminals labeled common go to the outside rails. So now what we're going to do is go ahead and turn our powerhouse back on. Our green light is on. I have A and U connected to this section of fast track. I'm going to take my throttle, I'm going to turn it up. As you can see, no lights come on in the car. A lot of people will say, whoa, my transformer's broken. It's simply not true. Your transformer, because your command base was on first, came up in command mode, and it's waiting for a command from your remote to tell it what to do. So we programmed this earlier to track 1. Because I'm on the A terminal, I'm going to press track 1 on my remote. I'm going to slowly turn the red wheel clockwise, and as I do, you can see the voltage on the track comes up. Once I have the voltage on the track, or I should say from the transformer, turned up through my remote, I can control that voltage manually using the handle on the transformer. If I turn the voltage down from the remote so that it's off, now the handle does nothing because the transformer is in command mode and it's waiting for its command from the remote to the base through the 455 kilohertz COM in through the antenna to tell the circuit board what to do with the voltage. So we can go ahead and turn that voltage back up. Our handle is open, therefore the voltage is on the track. If I press the direction button, power drops out. Press it again, power comes back on. So effectively the ZW is the equivalent of 4 Power Masters all in one package, because I'm able to put a straight 18 volts to the track, or I'm able to increase and decrease my track power manually, or conventionally if you will, to run conventional equipment. If I press the whistle button, it gives me a positive DC offset on the AC sine wave, which will trigger my whistle. Bell, a negative DC offset to trigger my bell on the train. What's great about the ZW is it does several things for you. One, it provides your circuit protection. If you have a short on your track, what will happen is your red light will begin to flash, and then the circuit breaker on your powerhouse will pop. What that does is that prevents your train from sitting there getting hot, melting wires, and ultimately damaging the electronics inside your locomotive. To reset a short, you simply press the circuit breaker on the powerhouse and it resets the short. Let's go ahead and short it out. My powerhouse just popped. I'm going to go ahead and reset my train on the track. I'm going to press my powerhouse circuit breaker. My green light came back on, but now I have no voltage on the track. I have to go back and say track 1, turn up my throttle to get the power back on the track. The other thing it does is, let's say that we have all of these outputs on, and there's a cornfield meet coming, 2 trains are going to collide. I can take my halt button on my remote and hit halt. As soon as I hit it, all of my track outputs go to 0. Power turns off. If I want to just turn track 1 off separately, we dial it back up. Again, track 1. Turn my power back on. If I want to turn just track 1 off, bring it to 0 volts, and I don't want to turn the throttle, I simply press the aux 1 or the straight arrow key and 0, and it shuts my power off. Same functionality you have with a Power Master. The biggest difference between a Power or a ZW and a Power Master is the Power Master has a switch on it to select between command and conventional. The ZW is conventional all the time, in that you have to turn the red wheel on the remote to bring your voltage up. Once you bring it up to 18 volts, it stays at 18 volts. You can run all the command engines all you want. Because you have to control that voltage in a conventional manner, you can run your conventional equipment off of any one of these channels on your ZW. Now, when you operate this ZW in a strictly conventional environment, and we'll do that right now, the way we're going to do that is we're going to shut this powerhouse off for the A terminal. We're going to unplug our legacy base so we have no power. We now have no 455 kilohertz signal present. We have no command-based signal present. It's turned off entirely. Not just disconnected from the track, but unplugged. Now what we're going to do is we're going to turn the powerhouse on for the A throttle. What our transformer just did is it came up in conventional mode. It did that because it automatically self-detected that there was no 455 kilohertz signal present. So now when I turn this throttle, voltage will be applied to the track. This transformer knows it's in conventional mode because there's no command signal. The same holds true for the B, C, and D throttles. I just have nothing connected to it. When you're in conventional mode, you have whistle and direction control for the A throttle. You also have a button on the back for bell for the A throttle. Same holds true on the other side for the D throttle. You have whistle, direction, and bell for the D throttle. B and U and C and U have no direction, whistle, or bell control. They're simply voltage on, voltage off. That's very similar to how the old post-war ZWs were. Sans the bell button. When we're in command mode, meaning the transformer is turned on after the command base is powered up, so it comes up in command mode, A and U, or the A throttle has whistle bell direction, the B throttle has whistle bell direction, C has whistle bell direction, and D has whistle bell direction, all off the remote. So operating in a command environment actually allows you to do more with the 4 outputs on your transformer than operating in a conventional environment. I want to take a moment and show you what it looks like inside your ZW. The way we'll do that is I've got a ZW here that I've taken the top off of and the circuit board out of. So go ahead and unplug this here for a second so I can put this out for you. Move this out of the way. Okay. What we have here is the guts of your ZW transformer. You'll notice that this outside throttle is controlled by this large wheel and this gear right here. Those gears are connected to a potentiometer. It's effectively the same exact thing you have inside your train to increase and decrease the volume of the sound system. You have 4 potentiometers inside your transformer case. These potentiometers are responsible for increasing and decreasing that track power when you're in conventional mode, and they also increase and decrease your track power when you're in command mode as well, although you have to actually dial that power up and down with your remote. The reason I'm pointing this out is because it is very possible for your throttles to get out of sync. And basically all that means is your potentiometer, when it's at 0 ohms of resistance, the throttle is off. As your resistance increases, the track power increases. If for some reason these gears skip and you turn your handle all the way down, maybe you're at 72 ohms instead of 0 ohms. So you've got a voltage bleed on the track, even when the handle is off. That happens. It was engineered into the circuit to prevent that. The way you prevent it is very simple. Simply take the powerhouse for the A throttle, plug it in, go ahead and turn that powerhouse off. We take our detent tool or our coupler T-bar and we hold down the program button with the power off. While we're holding that button down, we turn the powerhouse on. What happens is our red light will flash 5 times. Once it begins flashing, you can remove the detent. This red light flashes 5 times. On, off, 5 times. What that does is it recalibrates our throttles. Before you actually put this in and turn your powerhouse on, you have to ensure that all 4 handles are in the full down position. To run through that again, you simply take the programming detent, hold down the power or the program button, and turn the powerhouse on. The red light will flash 5 times. That tells you that the circuit board has taken both potentiometers on the A and B side and both potentiometers on the C and D side and recalibrated it. It's told the circuit board, hey, A&U says 72 ohms at 0 volts. We're going to look for 72 ohms to be at 0 volts. Now what we have effectively done is when throttle A is down and the potentiometer is at 72 ohms, it's going to know, hey, I shouldn't be putting any power to the track, so your voltage on your terminals will be 0 instead of having a small voltage bleed. The only powerhouse that needs to be plugged in when you recalibrate your throttles is the A powerhouse to the A and U terminals. It's also important to note that some earlier ZWs, if you, depending upon which model you have and which production run it came from, it is possible that when you turn this throttle up, these gears will skip. So it'll feel really loose. It won't feel like it's turning anything. There are some instances in some production runs that have actually a plastic bracket inside the ZW. And what happens over time is that plastic bracket begins to crack. When that cracks, it's the bracket that mounts these potentiometers inside. So what ends up happening is the gear on the pot actually lifts up when the handle gear is turned. And they don't engage, therefore the potentiometer doesn't turn at all. Through customer service, we have die cast, actually they're aluminum brackets that we have produced that go in and replace that original plastic bracket. And what it does is it holds the potentiometers firmly in place and prevents that skipping from occurring. I don't know if those are currently in stock, but I know that they're being made in the USA right now, and they should be available, I would think, by the end of February, beginning of March. But if your transformer happens to suffer from that, just get a hold of us here in customer service, and we'll get you straightened around. The circuit board that's inside, as I mentioned earlier, what I call Super ZW. The circuit board internally, this is what it looks like when it's out of the transformer. Here's the connectors that your powerhouses go into, faces out this way. But the jumper for your Super ZW mode is right up here, just to the right of the microprocessor inside, facing this way. So as you're looking at the ZW, it would be in the upper right hand corner of the board facing you. And basically all you do is you take that 2-pin jumper and you go over both pins. By jumping both pins, what you've effectively done is you've made it so when you program this ZW track 1, all 4 throttles respond to TR1 address. So if I have a really large main line and I have it broken into 4 power districts, meaning I've isolated the center rail with 4 gaps, I can connect A to the first power district, B to the second, C to the third, D to the fourth, turn all my throttles up to full blast. When I come up in command mode, I can take my remote, press track 1, turn the throttle, and bring all 4 terminals up to full 18 volts. The advantage there is by having those different power districts, I've got 10 amps per district. So if that main line is really large, like maybe 300 or 400 feet in diameter all the way around, I can theoretically run 4 or 5 or 6 separate trains and even run lash-ups or multiple unit consists of 3 or more locomotives per power district. So I can have 6 DC can motors in a lash-up pulling a train in power district 1, which is the A terminal, another one in power district 2, which is the B terminal, C, D, and so on. So I have more flexibility for controlling my power and putting a more available amperage out on my track, and so on and so on. Again, moving that jumper to put you in Super ZW mode is also going to allow you to control all 4 throttles just using the A terminal if you come up in conventional mode. Same basic concept. You've got a large railroad, you've got your power districts, you take legacy or command control out of the equation, I can control all 4 channels just with the A terminal. And then I can activate whistle, direction, and bell. And that will transmit on all 4 channels, A, B, C, and D. The ZWCs are pretty flexible devices. They give you a lot of choices in powering your railroad and your accessories. It is important to note that some earlier ZWCs, and again this is a problem because it's not all of them, it's just select production runs, but there are some ZWCs in the marketplace that have a microprocessor in the circuit board. And that microprocessor was, the code for that processor was developed long before legacy even became available. But there are some instances where the code inside the processor on some of those select ZWs will actually interpret the 455 signal that comes out of the legacy base as a halt command. So the end result is the transformer thinks that you're pressing the halt button, which is kill all the power, shut all the power off. In instances like that, what you need to do is replace that processor with a part number, and that part number is 691ZWPCS01. It's very simple to replace that processor with the circuit board in place. You don't have to take this out. It's a real bear to get this circuit board out of the casing. You just basically take the 4 screws off, pull the lid off, unplug the terminals, the connectors in here, and you can actually replace this processor in place. But by putting that ZWPCS01 processor in here, it'll prevent the ZW from detecting the 455 signal out of the legacy base as a halt command. So if you have a ZWC on your railroad and you're using legacy, you turn your power on, dial up all your track power, everything's running, everything's good, and all of a sudden, bam, all your track power goes to 0. The most probable cause of that is your processor's out of date. Just contact us at customer service. We'll be happy to send one to you. Just want to recap real quick the functionality of the ZWCs. You've got 4 throttles, A, B, C, and D. Out of the package with the 32930, you get basically 270 watts, 180 watt transfer, 360 watts, 180 watt powerhouse, another 180 watt powerhouse, gives you 10 amps spread across 2 channels. You can purchase 2 additional powerhouses to give you 720 watts or 10 amps of power per channel. You can move the selector inside. To use one address for all 4 throttles. You can use that same jumper to control all 4 throttles with one handle in a conventional mode. You can also use 7.5 amp 135 watt powerhouses. So you can have 2 10 amps out of the box with 2 more 7.5 amps, or you can add the 10 amps. It's totally up to you, totally based on what your needs are for your specific railroad. The 14125 Post-War Celebration Series ZWC, same functionality, same voltage output, same wattage capacity. It comes with 2 135 watt bricks. You can add 2 more 180s. You can remove the 135s and make it 4 180s, whatever you need for your railroad. I will point out that in some instances I have seen guys that use 135 watt powerhouses with their ZWs. And they'll have a locomotive on the track that has an AC motor. And when they first initially engage that AC motor to start running it, it'll actually kick the circuit breaker on the transformer. And the reason that happens is because there's a severe voltage spike when that 3-pole AC motor turns on, and that 7.5 amps on that that 135 watt powerhouse just can't handle that voltage spike. You can correct that by replacing that 135 watt with a 180 watt transformer, or powerhouse rather. And it'll look at that, it won't even bother turning the track power off, and everything will be fine. But pretty stout little unit. Once you understand how it operates, it takes a lot of the confusion out of the equation. And this is basically the predecessor to the ZWL, which hopefully will be out in June or July of 2012. And when it does ship, we'll get a product video with that on. Thank you for your time.